Hi guys, today I'm going to be walking you through the worked examples from exercise 3.5, which is transformations using matrices. So obviously this is from your Jacplus textbook, year 12, and the first thing they give us is a bit of a table, and it tells us all the mapping equations. And look, really, I would just not use that. I would work out your own equations each time so that you can understand how they work. Also of note is that as you're working through these, you might think, well, why on earth would you do a matrix equation for this? It's too much work. The reason is they give us some easier examples so we can practice with those easier examples. So you do want to use the matrix method so that you can get used to it and then decide, where it's going to be appropriate when there's harder examples. So let's look at this one here, and it's telling us that the graph is dilated by a factor of 2 parallel to the y-axis. So I don't like parallel to the y-axis. I prefer when they say from whichever axis, because then we know that it affects the opposite. But if the question gives it to you as parallel, you have to know that it affects the same. So it's parallel to the y, it's going to affect y. So I'm going to make a matrix equation, and this is how I do it. So x image and y image are the x and y values of that once you've done something to the original. So just pretend I have 1 over x, which actually, well, don't pretend, it actually is 1 over x. Then there would be some point on that graph, and that's xy, and it could be any value. It could be 1 and 1, it could be 2 and half, whatever the values are, it's just an xy point. And then you do something to that graph. So you transform it in some way. So let's pretend that we transform it over to here, which is not a dilation factor 2 parallel to the y-axis, but just to illustrate the point more. So that means that the xy point moves. And where that xy point moves to, well, we're calling that x image, y image. So image is the name of the transformed point there. So I now want to make a matrix equation which is going to show me this dilation factor of 2. So x image, I'm going to say, well, that's given to me by 1 times x plus 0y. So nothing happens to the x value in this here. We are dilating factor of 2 parallel to the y-axis, so we're going to multiply every y value by 2. So the x values just stay the same. Whereas the new y value, the image y value, is going to be 0x plus 2y. So notice that it's 2y, and as I said, parallel to the y-axis, so it's affecting the y value. So what we can do then is we can make a matrix out of that. So we can say x image, y image equals 1, 0, 0, 2. xy. And well, now we can multiply our matrix. And how we multiply matrices, it's row by column. So we're going to get x image equals 1x plus 0y. And notice that we're just going back to what we had in the beginning. But remember, the exercise is so that we can practice working with matrices. The next one, well, we go row by column, and we get 0 times x, so this is y image, equals 0x plus 2y. So now I can simplify that. X image equals 1x and y image equals 2y. And well, now it's that thing where we have to substitute. So our original equation was 1 over x. So we had y equals 1 over x. And now we've got to substitute in. So a lot of people are going to just put that into y. And that doesn't work because that's saying y image equals 2y. Well, no, we can't sub y image into y. It's like subbing a into b. That doesn't work. So I have to rearrange. I can see that x is going to equal x image and y is going to equal half y image. So now I have y here, I have y here, so I can substitute. So I get half y image equals 1 over x image. And then, well, let's make this neat, and we're going to multiply both sides by 2 to get rid of the half. y image is going to be 2 over x image. And for our final transformed equation, we're not going to include the image signs in there. We're just going to write it like that. So that's the first one. So as I said, it's not necessary to use the matrices in order to do these, but it's about practicing making the matrix equations. And again, I stress that I went from here to my matrix equation and then I went back to here. Not because you would do that necessarily. I'm just showing you how you will end up getting to this point. So let's go to the next one. So this is the graph of y equals x cubed reflected in the y-axis. So y equals x cubed, and well, x image and y image, and we're reflected in the y-axis. So the reflection will affect the opposite. So this is going to be negative 1x plus 0y, and well, nothing's happening to our y value, so it's 0x plus 1y. So the matrix we get for this is going to be x image, y image equals neg 1, 0, 0, 1. And we're multiplying that by our original point. So let's do that, and we should get back what we started with. Again, we're just practicing using the matrix equations here. So negative 1 times x, negative 1x, 0y, 0y. Now we go row by column, 0 times x, so y image equals 0x, plus 1 times y is 1y. So x image equals negative 1x, and y image equals y. Again, you are not going to be able to sub them in until you get x and y. So, well, x is just going to become negative 1x image, or negative x image. You don't need the 1 there, obviously. And y is just y image. So now we can sub that into our original equation of y equals x cubed. And, well, this is just going to give us negative times negative times negative is negative. So y image equals a negative x cubed. Or we don't want to leave the image there in the end. So that's our final answer there. And look, again, you could probably find this straight away. You could probably write this answer straight away just from reading the question. You wouldn't need to go through all that, but it's the practice that we want to get. So don't be tempted to not do the matrices there. The last one, the graph of y equals tan x, translated pi on 4 in the negative x direction. So let's see, y equals tan x, and translated pi on 4 in the negative direction. So x image and y image. So this time we're not dilating or reflecting, and dilation and reflection are the multiplication matrices. So x image is going to be 1x plus 0y, and y image is going to be 0x plus 1y. So that's going to end up giving us our matrix. What we then do, because we're going, I think it was negative pi on 4, I'll just double check. Yeah, pi on 4 in the negative direction of the x-axis. So we're going to be subtracting pi on 4 here. And this, well, it's just 0. So you don't really need that 0 there other than to make the matrix. So now I can make my matrix equation, and these here, this is multiplication because it involves the reflections and dilations, of which there are none. But in any case, we will put them into the matrix equation for the sake of completeness. So 1, 0, 0, 1. Notice I've just taken the values from in front of the x and y's and put them in their correct places. X, Y. And then, well, I always add the translation matrix. So the translation matrix is any vertical or horizontal shifts. So we're going pi on 4 in the negative direction and, well, 0 here. So because we're making a matrix equation, we're going to need to write the 0 there, the same as why we write the zeros there and there. We won't be able to do the matrix arithmetic without it. So let's expand these row by column. So multiplication of matrices, so x image equals 1 times x is 1x, 0 times y is 0y, and then I've got this plus negative pi on 4. So let's put a negative pi on 4 here. And y image is going to be row by column again. So 0 times x is 0x, 1 times y is 1y, and we've got a plus 0 there, which of course is unnecessary. I've just put it there for the sake of completeness. So I'm going to neaten them up. X image equals x minus pi on 4, and y image equals y. And this is the really magic part, because this is the part where you realize why in the transformation table, like if you have a parabola of x plus 2 squared, you go in the negative direction. So we go the opposite. And until, unless you did this in year 11, until then, you just have to accept that when it's connected to the x by way of the brackets or in the square root sign or whatever the type of graph is, when it's connected to the x, we move in the opposite direction. But now we can actually see why that is. And the reason is because of y equals tan x. You can't sub x image into x or y image into y. You can't do that because that's the same as subbing a into b. They are different variables. So before we can sub in, we need to make sure they're the same. And x therefore equals x image plus pi on 4. And well, y still equals just y image. Now, this is the opposite. So we can say y image equals tan of x image plus pi on 4. And we're moving pi on 4 in the negative direction of the x-axis, and we have a plus pi on 4. Why? Because when we do either mapping or matrix transformations, we have to rearrange to solve for x rather than x image. All right, and just to complete it, I would not have the image on there. So that would be my final answer. All right, now look, let's move on. We now move to one where we have combination transformation, and this is slightly more indicative of where you might use the matrix transformations. Still, I feel like I could do this more easily without the matrices, but again, it's the practice of using the matrices that we want in this exercise. So use matrices to dilate the function by a factor of half parallel to the x-axis. So that's the first thing. Reflect it in the y-axis, and then translate 2 units right. Okay, and then we're finding the equation of the transform function. So I'm going to do it in parts. You may well be able to do it in one go, but just so you can see clearly how it works, I'm going to do it in 3 separate parts. So I'm going to first deal with the dilation. So the dilation matrix is going to be, well, x image and y image is given to me by half parallel to the x-axis. That means it affects x. And y image is 0x plus 1y. So just the dilation is given to me by half 0, 0, 1. So that's my dilation matrix. So I'll say x image, y image equals that. And we're timesing that by our original point. So that would be my dilation. Now what happens after that? So this is the first thing that happens. The next thing that happens is going to go here. And the order is important. So if you haven't done a lot of matrix arithmetic, multiplication of matrices, you must do it in the correct order. Otherwise you can get very different answers. So my reflection in the y-axis, so we're reflecting in the y-axis, it affects the opposite, affects x. So x image equals negative 1x plus 0y, and y image equals 0x plus 1y. So my matrix for this one is going to be neg 1, 0, 0, 1. And that goes in there, so I'm actually going to put that in there now. So let's get rid of that. So neg 1, 0, 0, 1. And well, now the last bit is we are translating 2 units to the right. So if I'm translating 2 units to the right, let's do that. So the translation matrix, 2 units to the right, we're going to be adding on 2 units right is affecting the x, and then just for 0 for y. So I don't really need that plus there. I just write 2. So I might try and make that a little bit smaller just so I can fit it all in here. Half 0, 0, 1. and xy. That's my original point. So look at this. This is a multiplication times the original point. So dilation, reflection are multiplication. And then my translation, I always add the matrix, the translation matrix. So 2, 0. And then, well, now I can go about expanding it and making my new equation. So let's do that. So the first thing I need to do is multiply the two matrices together. And you may well get that, you might be able to get this matrix in one go. You might not need to do two and multiply them, but I'm going to because I wanted to show you the steps slowly there. So x image, y image equals, so multiplication of two matrices there, it's row by column. And if you have forgotten or if you haven't done matrix multiplication, it's a good idea to color code it as I'm doing here. So I say -1 times half, and I'm going to write this out, -1 times half, and then I say plus 0 times 0. So -1 times half plus 0 times 0. That's where those values are coming from. And that belongs, this is the top, and here's the bottom. This is left, and this is right. So I'm doing the top left, and that becomes my top left value of the matrix there. So let's do the next bit, and I'll do this in blue. So now I'm going to do top right. So I'm going to get -1 times 0. So over here, I've got -1 times 0 plus 0 times 1. So that is my top right. So I'm taking the top or bottom value from the first matrix, and I'm taking the left or right from the second one. Let's go to the next bit. I don't want that circled, I'll just get rid of that. Now let's go a different color. And now I'm going to go bottom left. So bottom left, actually let's put those in the colors too. So the bottom left, we're going to have 0 times half plus 1 times 0. And then finally, I'm going to have pink. I'm going to have bottom right. So the bottom right is going to be 0 times 0 plus 1 times 1. Okay, so now that I've done that, let's neaten that up. And really, I mean, you can probably do those things in your head so you can get those values straight away. You don't need to write 1 times half and 0 times 0 and stuff like that. So look, let's do that. And I'm going to get -1 times half is -half plus 0 times 0 is 0. 0 times half is 0 plus 1 times 0 is 0. -1 times 0 is 0 plus 0 times 1 is 0. And 0 times 0 is 0 plus 1 times 1 is 1. So this is my dilation / reflection matrix. So that's the combination of those two transformations. Now I've got xy here, and I'm just going to put plus 2, 0 here. So let's expand it, and then we can use that. So -half 0, 0, 1. X image, Y image, I'll just rewrite it here. -half 0, 0, 1. XY plus, I think it was 2, 0, wasn't it? Let's double check. Yep. Okay, so let's expand it. We get X image equals -half times X is -half X plus 0 times Y is 0Y plus 2. So the 2 is on the same level as the X. Now I do the Y values. So now I'm going row by column this way. Y image equals 0 times X is 0X plus 1 times Y is 1Y and then plus 0. So let's neaten those up. So X image equals -half X plus 2 and Y image equals, well, Y. So we now have our how we get the image. So we can say we get the X value, the new X value, by multiplying every original X value by -half and then adding 2. And the y values, well, they're going to stay the same. So let's go back and see what the equation was. So y equals the third root of x. I'm just going to write that here so we remember. And now I can't sub this in like this. So I can't put that in. That's going to be the mistake a lot of people make, to just sub in that. But that's, as I say, like subbing A into B. You wouldn't do that. So neither would you sub X image into X. So if this said A equals half X plus 2, you'd know you can't put that into X. But because it's X image, people get a little confused. They look similar there. So I'm going to rearrange. So minus 2 on both sides gives me X image minus 2. Now I'm dividing by negative half. That means I'm timesing by negative 2. Oops. X equals. So there's my X value. And of course, Y equals Y image. So let's sub it in. And I get Y image equals the third root of negative 2 X image minus 2. And look, you can leave it like that, or you could, well, you have to get rid of these. But after we get rid of those little dashes, you can leave it like that, or you could expand it if you wanted to. But really, I see no need to do that. So I'm not sure what they'll have as the final solution in the book, but both of them are right. This looks quite nice too, doesn't it? But look, either of these are just as right as the other. So that's matrix transformations. There are the worked examples. And as I said, look, this table may be handy because you can see, what your matrix equations are right away. But it's really good to work them out from scratch so you can really understand how the matrix equations work. It's also important, as I've said a number of times, use the matrices even on the easy examples, because that's the whole point. You get better at using the matrices by starting with the easy ones and working your way up to the hard ones. Right, that's all from 3.5.